Okay guys, hi, I'm Johnny, this is Samuel, this is Michael, and that's Stuart filming over there. Today we're going to be talking about Newton's 3 laws of motion and his law of gravity. Okay, hi, now I'm just going to talk about Newton's first law of motion. Newton's first law of motion states that if an object is in a state of motion, for example, if it's moving at a certain speed, it'll always be moving at that speed unless some form of external factor comes in. For example, let's take this stick over here. If I was to drop it, it would keep on going, but since the floor acts as an external factor, it'll stop it from moving. You can clearly see it's now stopped. And now, if I use my feet as an external factor, it's now moving again. So that's just a simple way to explain Newton's first law. It also works out that when you're bouncing a basketball, same thing comes in, ball come up, but then when you put in the external factor of say your hands, you knock in a different direction, it's going to go in that direction until it hits something else, which would also count as an external factor. Okay, so now I'm going to be talking about Newton's second law. Pretty much what the second law states is that an object with mass, if you want an object with mass to accelerate, you need a certain amount of force. That certain amount of force may vary depending on how much mass the object has or how much acceleration you want to put into it. So for example, if a car weighs a lot and you want it to go at a slower speed, it would require more force than a car that weighs a lot less that you want to go at the exact same speed. And that works vice versa. So if you want a car to go faster but it's lighter, it'll be easier. But if you want a car to go really fast but it's heavier, it's going to be harder and you'll need a lot more force. And the way we figure this out is through the mathematical equation F equals ma, which means the force equals the mass times the acceleration. So if I have a car that weighs exactly 1,000 kilos, I want to push the car because say I ran out of fuel. I want to make it go 0.05 meters a second. That would require 50 newtons of force.
Go.
Okay guys, right now we're about to explain the law of gravity. Newton's law of gravity simply states that if an object has mass, it has its own gravitational pull, which pulls towards its center. So for example, everything has mass, although we don't have enough mass for the gravitational pull to be recognized. Clearly, it doesn't look like I have any gravitational pull, yet I still have mass. But the Earth, for example, has a lot of mass, meaning it has a lot of gravitational pull. And as you can see, I'm standing on the Earth now. The thing that keeps me on the floor is the Earth's gravitational pull pulling me towards the center of the Earth. If I was to jump off a building, I fall and hit the floor. And in the same way, the Sun,
Please do.
this whole solar system orbits around the Sun because the Sun's a lot larger than the Earth, giving it much more mass, which gives it much more gravitational pull. Okay, wait. So as you can see, whenever Samuel bounces the ball, it comes back up. Not only is this an example of gravity, how he goes to the ground, it's also an example of Newton's third law of motion. Every reaction has an equally opposite reaction. Depending on how hard he bounces it on the floor, the ball will come back up at a similar pace. Alright guys, we have Samuel and Michael here. They're going to pretty much show us the law of gravity. So can you guys jump up and down for a bit? So as you can clearly see, the mass of the Earth is drawing them towards the center. Every time they go up, gravity pushes them back down. Alright, now we're going to explain Newton's third law of motion. Pretty much what Newton's third law of motion says that everything you do, every single thing you do has an equally opposite reaction. For example, if I have a ball and I'm bouncing it on the ground, it's going to come back up based on how hard I threw it on the ground. And exactly like when we're at camp and rocking the canoes, if the canoe would go a little bit to the right without capsizing, it would move back to the left about the same amount. But good luck without capsizing it. Finished.